day, students. Welcome back to the second episode of your 10 days Jamb Rhema with exquisite tutorials. Actually, the second chemistry episode of your 10 days Jamb Rhema with exquisite tutorials. The first time we talked about so many things in chemistry. We talked about matter, we treated separation techniques, we treated pure and impure substances, and we treated so many things under matter and under atoms and molecules. And today we are looking into a huge aspect of Jamb chemistry where so many students always wants to avoid, but you cannot avoid it so long you want to have a very good score in Jamb. And today we'll be looking into your metals and your non-metals. Okay, what are metals? Before we go straight to the questions that we need to attend to. Talking about metals, we made us to understand that your atoms have three subparticles: your proton, your electron, and the neutron. We made us to understand that the protons are the positive, electrons are negative, and neutrons are neutral. But the proton and the electron are the ones that are inside the nucleus of an atom. Now we have metals. Metals are those elements that has a positive charge, while non-metals are those elements that has a negative charge. So when we are talking about metals and non-metals, we are talking about the whole of all the elements in your periodic table, their characteristics and their attributes. So let's proceed. Now today, let's look into our first Rhema question. Question 1. Why is hydrogen gas not found in the atmosphere? Now, constituent of air. Okay, let's do our answers here. Let's take our answers here. Why is hydrogen gas not found in the atmosphere? It said it readily reacts with carbon 4 oxide. B said readily reacts with oxygen. C said readily reacts with nitrogen. D said reacts with carbon monoxide. Now, the constituents of air in the atmosphere, we are made to understand that the constituent of air in the atmosphere contains oxygen, it contains carbon 4 oxide, it contains nitrogen, and it contains noble gases. Noble gases. There is no hydrogen. There is no hydrogen. No hydrogen in the atmosphere. Now, we're meant to ask, why is it that hydrogens are not found in the atmosphere? Is it because hydrogen reacts with oxygen, it reacts with carbon 4 oxide, it reacts with nitrogen, or it reacts with carbon monoxide? This carbon monoxide is already out of the equation, so no, D is wrong. Now let's assess option A. Option C, A says CO2. Now, if you check most compounds that contains hydrogen, the most common compound that contains hydrogen is what? Is water, H2O. This is because of the affinity that hydrogen has with oxygen. So whenever hydrogen sees oxygen, they react to form H2O. It's as simple as that. This is the reaction. You have hydrogen gas plus oxygen gas to give you H2O. This is just the reaction between hydrogen and oxygen. So the main reason why hydrogen are not found in the atmosphere is because of option B, which says that your hydrogen reacts with oxygen. Grab that. Okay, now let's go straight to question number 2. We'll be using this question number 2 to explain our electrochemical series. Now let's go forward. Let's look into question number 2. Question number 2 says, Which of the following metals will react with water only in the form of steam to liberate hydrogen gas? Now, this question is bringing us to our electrochemical series. Now, in our electrochemical series, we have the order of reactions. Okay, let's just take some metals. We have metals like sodium. We have metals like calcium. We have potassium. We have magnesium. We have so many metals, and we have I think we have zinc. We have zinc. We have hydrogen. We have copper. I'm just giving you a rundown. I'm not giving you the full electrochemical series. We have copper. We have aluminium, and we have silver. We have silver, Ag. Okay, now let's proceed. This electrochemical series explains something to us. What is it making us to understand? Electrochemical series is making us to understand that in a chemical reaction, potassium is supposed to actually come before most of this. Yeah, potassium is supposed to come before sodium and the rest. But I just did a rough walk to explain something to us. It's not that I'm showing us the right format. Potassium, sodium, calcium, magnesium, zinc, and the rest. Now, this thing is making us to understand that in a chemical reaction, now we are focusing on hydrogen. In a chemical reaction, all these elements ahead of hydrogen is going to displace hydrogen in a chemical reaction, or it's going to displace hydrogen from its compound in a chemical reaction. Now, let's say, for example, we have something like sodium reacting with HCl. This thing here, this sodium is going to displace hydrogen from this compound, hydrogen chloride, to give sodium chloride. Displacing hydrogen to give you hydrogen gas. This is what we are trying to explain here. This is actually what we are trying to explain here, that this will displace this to give you hydrogen gas. Now, more reactive elements like potassium, like sodium, like calcium, and okay, let's say like magnesium. These reactive elements that are very reactive will displace hydrogen from water, from normal water. So these elements will displace hydrogen from water. But other elements which are, let's say, a little bit more reactive than hydrogen, but not as reactive as the most reactive element. Now, if you check the most reactive element, you are seeing alkaline metals and alkaline earth metals. Those that are in group 1 and in group 2. I don't know if you're getting me. But the less reactive elements can only displace hydrogen in a steam form. That means when it can only displace hydrogen from water when the water is in steam form, that is in gaseous form, not in solid and not in liquid. Now, example of the less reactive elements, I actually forgot to put iron here, is iron. And we'll have other examples. So now, when iron cannot react with cannot react with water, cannot react with cold water, but iron can only react with water when steam. Can only react with steam, not ordinary cold water. So when you have a cold water, iron cannot react with water to displace hydrogen, but iron can only react with water, with steam to displace hydrogen. So which of the following metals will react with water only in form of steam to liberate hydrogen gas? How do you answer this question? Sodium is already a very high reactive metals. Just like I told you guys, high reactive metals will displace hydrogen in liquid, or will displace hydrogen from water or any water molecules. So sodium is out of the equation. Calcium is out of the equation. Now copper. I want to show you something about copper. Here, after hydrogen in your electrochemical series, you see copper, you see aluminium, you see silver. This thing is to let you know that this element cannot displace hydrogen either in liquid form or in steam, because hydrogen cannot displace hydrogen from water either in liquid form or in steam, because hydrogen is higher than them in the electrochemical series. So the option here is iron, which is not as reactive, which is a less reactive element compared to the potassium, the sodium, the calcium, the magnesium, the alkaline, and the alkaline earth metals. Now we are still going to use this electrochemical series to answer our question number 3, which says, which of the following oxides remain unchanged when heated in hydrogen? Now let's do some kind of tricky questions. Which of the following oxide remains unchanged when heated with hydrogen? We have iron oxide, we have lead oxide, we have iron oxide, we have copper oxide, we have zinc oxide. Taking us back to our electrochemical series, let's assess our options. Option A said lead oxide. Option A. Now, what this question is trying to prove, or is trying to make us to answer, is that just like we said that elements below hydrogen in the electrochemical series cannot displace hydrogen, or hydrogen cannot displace elements higher than it in the electrochemical series. Now, if these oxides are heated with hydrogen, it means that they are telling us that is it possible for hydrogen to displace for hydrogen to displace lead, displace iron, displace copper or zinc? Which of the following elements would hydrogen not be able to displace from its compound? Now, just like I made us know when I was explaining the first one, hydrogen is higher than lead in the electrochemical series. So definitely when you react lead with hydrogen, lead oxide with hydrogen, hydrogen will displace lead because hydrogen is higher in the electrochemical series. So option A is out of the equation. Option B, we have iron oxide. Option B, we have iron oxide, O2O3. Option B, iron oxide. If you check, iron oxide is not that as reactive as iron oxide is not as reactive as the other alkaline and alkali earth metals. And you discover we said when heated. Mark this heated. This when heated made you to know that iron is a bit higher than hydrogen in the electrochemical series. But in our question, in this question too, we are made to understand that iron can displace hydrogen from steam, not ordinary water. Steam means a water that is heated. So if iron can displace hydrogen when steam, it also means that iron oxide can react with iron oxide when heated can react with hydrogen. So which means that this is out of the option, because this one when heated will react with hydrogen and this compound will be broken. It will be changed because of the steam. Now we have copper oxide. Copper is below hydrogen in the electrochemical series. So definitely hydrogen can displace copper from its oxide. Now this is zinc. Zinc is a very reactive metal which is higher than hydrogen in the electrochemical series. In fact, we can even react with hydrogen, can even react with water to displace hydrogen. So which means that if you bring in zinc oxide and you are bringing in hydrogen to come and displace zinc from its oxide, hydrogen cannot displace zinc from its oxide because zinc is far higher than hydrogen in the electrochemical series. So the correct answer is option D. Make sure you understand this electrochemical series. It's going to come out. This is one of the major questions that comes out in your metals and non-metals. Understanding, most times they always give you hydrogen. Understanding the elements that are above hydrogen in the electrochemical series, and know that the ones that can displace hydrogen in water and the ones that can displace hydrogen in steam, and also note the ones that are below hydrogen in the electrochemical series, because you can only displace an element from its compound when you are more reactive than the element. Now let's take other questions and use it to treat other aspects of metals and non-metals. The liquid substance M. Now, one thing I want to tell you about chemistry question is that when tackling chemistry questions, do not just tackle chemistry questions because you want to answer it. First thing first, try and understand the questions. Sometimes the problem where students fail chemistry questions is their inability to want to understand the question first. The liquid substance M reacts with sodium triazocarbonate 4. Okay, number 4. We are told that the liquid substance M reacts with sodium triazocarbonate 4. Gives a gas which turns lime water milky. Therefore, M is. Now, we are interested in M, and we are interested in the gas that turns lime water milky. Now, first of all, let's proceed. M reacts with sodium triazocarbonate 4 to give a gas which turns lime water milky. Now, on the option, M is an acid, M is sodium tetraisosulfate 6, M is potassium iodide, or M is an alkali. What is M? Okay, now let's proceed. First of all, let me tell you about the gas that turns lime water milky. There's a gas that turns lime water milky, and the name of that gas is CO2, carbon 4 oxide, in case you don't know. We are going to see, in fact, there's no way you're not going to see a question relating to carbon 4 oxide in your Jamb questions. Okay, now, if M reacts with this to give this, which of these options here will I react with this to give me CO2? That's what we are interested in. So that is why it's good to understand the question. Is it an acid? Is sodium tetraisosulfate 6, sulfate 4? Is it potassium iodide? Is it an alkali? Now, potassium iodide is out of the question because there's no way you will react potassium iodide with sodium triazocarbonate 4 to get carbon 4 oxide, to liberate carbon 4 oxide gas. That is not possible. You want us to try it? This is Ki plus NaCO3. There's no way you're going to get carbon 4 oxide from here. You can just get potassium, CO2, sodium iodide. So it's not working. Now, should we say it's sodium tetraisosulfate 4 out of the equation? There's no way carbon 4 oxide can come up this. Instead of stressing us, let's just go straight to the point. When you react an acid with sodium triazocarbonate 4, it liberates carbon 4 oxide, and it is carbon 4 oxide that turns lime water milky. So therefore, M is going to be an acid, a dilute acid. Okay, now let's try it. Let's say M is HCl. HCl plus NaCO3. Now, remember when I was teaching you electrochemical series, definitely sodium will displace hydrogen from hydrogen chloride. You're not going to have sodium chloride plus, remember there's hydrogen here and there's oxygen here. When I started, I told you guys the affinity that hydrogen has for oxygen to produce water. So definitely you are going to have your water, your H2O. And the last thing that is remaining here is your CO2. So definitely when you react dilute acid with sodium triisocarbonate 4, it liberates carbon 4 oxide, which in turn turns lime water milky. So once you see all this question, just close your eyes, look at the options and click it. It's as simple as that. Okay, now let's proceed. Number 5. Which of the following will give lime water used in the laboratory for the detection of carbon 4 oxide? Now, I told you guys that carbon 4 oxide turns lime water milky. That is actually what they use in the detection of carbon 4 oxide in the laboratory. When you see an unknown substance, when you introduce it to carbon 4 oxide, when you see an unknown substance, when you introduce it to lime water, once it turns milky by the presence of lime water, that means there's a presence or there's a trace of carbon 4 oxide in that substance. Do not forget that. Nobody will tell you that apart from explicit. Okay, now let's proceed. Here we have CaSO4, we have CaHC, calcium hydrogen tetraoxosulfate, 4. We have calcium hydroxide, and we have calcium triisocarbonate 4. Now, when we are talking about lime water, here now, since we know that CO2 is what turns lime water milky, what you should be interested about in knowing is, what is lime water? Lime water, okay, number 5. Lime water is actually the aqueous solution of calcium hydroxide. Aqueous. Now, when you have calcium hydroxide, your normal calcium hydroxide solid, and you introduce it to water to form the aqueous solution. That aqueous solution is what we call lime water. The aqueous solution is what we call lime water. So when you check your options, you are seeing this is calcium hydroxide in a solid form. Are you getting me? In a solid form. So the only thing that will give you lime water here is adding water to calcium hydroxide solid to give you the aqueous form of calcium hydroxide. So with this, you have gotten your lime water. So just click on this and move on to the next class and move on to the next option. Now let's proceed. Okay, now question 6 says, in which of the following pairs of metals are the two members extracted by electrolysis? Now, this one is talking about extraction of metals. Just like we are made to know that most metals are highly reactive, so they do not exist in free state. Now, the reason why metals, most reactive metals like the potassium and the rest do not exist in free state is because they are highly reactive, so they exist in compounds or in molten states. Now, this question is asking us, in which of the following pairs of metals are the two members extracted by electrolysis? Now, if you do not understand the basis behind extraction of metals and the rest, you wouldn't understand this question. Here you have copper and zinc. Here you have lead and calcium. Here you have magnesium and zinc. Here you have magnesium and calcium. Now, common sense as a good student or somebody that has a basic foundation in chemistry we easily figure out what was wrong here and fish it out. You want me to figure out what was wrong before we tell you the real answers? Now let's see. If you see the pairing of these two elements, we have copper and zinc. What's the difference? Copper is a less reactive element, below hydrogen in the electrochemical series. Zinc is not so reactive, but above hydrogen in the electrochemical series. You might say, for this reason, these two cannot pair. Let's say lead and calcium. Calcium is very reactive. Lead is very reactive. So there's a suspicion somewhere. Magnesium is reactive. Zinc is not very reactive. You need to suspect this. But this is the only option that the two match together. Magnesium is very reactive. Calcium is very reactive. So these two match together. A novice that does not understand what the question is actually all about, we want to go with this. So sometimes you can actually get some questions right in your Jamb exams without knowing the answer. Now this is what they were talking about. We have two major ways of extraction of metals. We have one, extraction of metals. One of the major ways of extraction of metal is electrolysis. Number two is chemical reduction. Now, the major question you're going to ask yourself, which metals can be extracted using electrolysis and which metals can be extracted using chemical reduction? Once you know this, you have keyed any question that has to do with extraction of metals. And trust me, you are going to know it here because you are at the right place at the right time. Exquisite. Okay, now, highly reactive metals like potassium, calcium, sodium, magnesium are extracted from their ore through a process known as electrolysis. But less reactive metals like copper, like zinc, like lead, are extracted from their ore through a process known as chemical reduction. So the two difference between electrolysis and chemical reaction is the metal you are extracting. If it's a highly reactive metal, they are extracted through electrolysis. If it's a less reactive metal, they are extracted through chemical reduction. So the only two, now here they are talking about electrolysis. The only two metals here which are highly reactive are magnesium and calcium, which is to say that this is the right option. These are the only two metals that can be extracted through electrolysis. Now let's go to question 7. I think we'll be ending this Rhema on this question. Then we'll continue with metals and non-metal in our next video so that you can understand very well. Option 7 said the most reactive halogen is, we have chlorine, we have iodine, we have bromine, and we have fluorine. Now, I want to use this opportunity to teach us reactivity. In your area, I was explaining the electrochemical series for us and how it functions. Now, in the reactivity, we'll have your periodic table to be like this. I'm just doing a rough sketch, and you have your metalloid around here. Now, when we are talking about your metals are the ones that are at the upstream end, your most reactive metals. Let's say the alkali metals, while the least, the most reactive non-metals, the halogen, which is the last group before the noble gas, the ones that has, this one is +1, and this one has -1. Okay, let me make this thing clearer for you to understand. Let me do the sketching a little bit more understandable periodic table. Let me sketch this thing more understandable to you. Okay, let's say this is how your periodic table looks like. Okay, we are only using some part. Let's say here is your most reactive metals plus 1, your most reactive metals minus 1. Now, these are your alkaline metals, these are your halogens. Remember, your alkaline metals are the most reactive metals, your halogens are the most reactive non-metals. We have potassium here, we have sodium, we have fluorine here, we have chlorine here. Now, when it comes to metals, the reactivity increases down the group, which is to say, it's sodium before potassium. We have sodium and we have potassium. The reactivity increases down the group, which is to say that your potassium is more reactive than your sodium. And we have other alkaline metals below potassium. We have the francium, cesium, and the rest. So your reactivity increases down the group for your alkaline metals. But when it comes to the halogen, your reactivity decreases down the group, which is to tell you that the halogen at the top is more reactive than every other halogen below.